If you've been paying careful attention, you will notice that we have not yet taken the derivatives of logarithmic functions, so things like log base 7 of x or natural log of x. And this is the last big class of functions that we need to learn how to differentiate, and we're going to do that today. I have in the yellow boxes here the final answers. These are going to be the formulas that you'll need to memorize. But I want to show you how we get to those formulas first. You're not going to have to do this process every time. We're going to do this with the example of log base 7 of x. So we want to differentiate this. So again, we don't know how to differentiate this, so we need to use other techniques that we know. And so what I'm going to do is I'm going to start out by rewriting this in exponential notation. So we know that logs can always be rewritten in exponential notation. So this is the equivalent to saying that 7 to the y is equal to x. You might have to remember that from our pre-calculus class. And so what we're going to do is we're going to differentiate both sides of this equation. The derivative of x is just 1, so that side's easy. And then if you remember from last semester, when we take the derivative of a to the x, we get a to the x ln of a. So if I have 7 to the y, we're going to get 7 to the y ln 7. But then because y is a function of x, we're doing implicit differentiation here. So we're going to get a dy dx there. Okay, so that's pretty nice. So now we can solve for dy dx. So dy dx, if I just divide both sides, I'm going to get 7 to the y ln of 7. Okay, my final expression was y is equal to something in terms of x. So I don't really love the fact that my expression now has a y in it. So let's replace this. We know that 7 to the y is equal to x. So I can replace my 7 to the y with x. And so this gives me 1 over x ln of 7. And what this tells me is it tells me that the derivative of log base 7 of x is this expression. Okay? We notice that there's nothing special about the 7. If I replace the 7 with any other number, I would just replace this with any other number. So I could see in general that the derivative of log base a of x is 1 over x ln of a. And that's what we have in this box over here. So that's one equation that you need to memorize. And then there's the very specific case if a is equal to the constant e, then we're going to get 1 over x ln of e. ln of e is just 1. So we get 1 over x. In log base e of x, that is so special that remember we call that the natural log of x. So what this is telling us is that if I look at the very specific case where a is equal to e, then the derivative of natural log of x is 1 over x. And I'm giving you that as a separate case to memorize because we use this so often. Typically, I don't like you to memorize two separate formulas, especially when we can derive one from the other one, but we're going to use the derivative of natural log of x being 1 over x far more often than we're going to use the other one. So I do want you to memorize both of these. Okay, so really all we have here is just two new formulas to memorize, and then we can apply this with like all of the other techniques that we've used before. So we can mix this in with a product rule, a quotient rule, a chain rule, and that's just really where things get interesting. So let's do a few examples here. So if I look at this first one, I have log base 10 of x. So to take the derivative of that, I'm going to get 1 over x ln of 10. I have an ln of x, so the derivative of that will just be 1 over x. And remember that 6 is a constant, so it's just going to be 6 times the derivative of ln of x. So we get 6 times 1 over x, which you could certainly write as 6 over x. And then 7 again is a constant, so it hangs out front. The derivative of log base 8 of x is 1 over x ln of 8. And that's all we get there. You should try these other ones on your own before you watch me finish them up. Okay. So let's see. This next one looks like a product rule because I have an x times a log base 9. So I'm going to use the product rule. The derivative of x is 1. So we leave the log base 9 alone. Then we leave the x alone. The derivative of log base 9 is 1 over x ln of 9. Sometimes these will cancel out nicely. And so let's just go ahead and simplify things. The x's cancel out here. So we could write this as log base 9 of x plus 1 over ln of 9. Remembering ln of 9 is not the same thing as log base 9 of x. Those are not the same thing. Okay. Ooh, this next one looks like I have a function inside of my natural log. So this is going to be a chain rule. So my outside function in this case is ln of x My inside function is 3x squared plus 2. The derivative of the inside is 6x. The derivative of ln is 1 over x. And so when I put this all back together, I'm going to get y prime. I'm going to plug my inside function into the derivative of my outside, 3x squared plus 2, and I'm going to multiply all of that by 6x. Okay. Sometimes some textbooks will have you memorize this as a specific case of the chain rule. They'll say, well, what happens if you have natural log of f of x? What's that derivative always going to look like? Don't memorize more formulas than you need to. Just apply the chain rule to the natural log. Much easier. Okay, this next one looks like a quotient rule. We're getting a good mixture of all our rules here. So I'm going to have low times d high, which is 3x squared minus high. My d low will be 1 over x ln of 6. I'm not going to try and simplify this one. And then I have low squared in my denominator. Okay. These last two look like chain rules to me because I have a function inside of a function. I have sine inside of natural log, and I have natural log inside of sine. And so kind of the order of them in these two problems is different, so the final answers will be different. So in the first one, my outside function is ln of x. My inside function is sine of x. Derivative of ln is 1 over x. Derivative of sine is cosine of x. So when I plug sine into 1 over x, I get 1 over sine of x, and then I multiply all that by cosine of x. Ooh, this simplifies nicely. We notice this is cosine over sine, which is cotangent of x. If you didn't notice that simplification, that's okay, but it simplifies nicely, so we might as well do it. This next one, my inside and outside functions have switched. So my outside function is now sine. Its derivative is still cosine. And my inside function is ln. Its derivative is still 1 over x. So now I'm going to plug ln into cosine. So I get cosine of ln of x, and I'm going to multiply by the derivative of my inside function. Okay, so notice that these last two like start out looking very similar, except for my inside and outside functions are flipped around. That is going to matter greatly in the derivative because when we do the chain rule, the outside and inside functions are not interchangeable.